So I'm here to talk through classwork number 6 on correlations. This answer sheet is posted on Canvas, but in case there are things that are unclear, I'm happy to go through the normal narration like I do when I put stuff up on the board. So recall that we did numbers 1, 2, and 3 in class on Wednesday, the 11th, but those answers are posted in case you weren't in class on Wednesday. What's new is the added questions for the SPSS stuff. So recall, if you're looking at the sheet that you got as a hard copy in class, that doesn't have the SPSS output on it. So make sure that you look at, when you're doing these problems, the revised classwork sheet that has the CV at the end of the file name. Those are the ones that I added the correlation matrices, the SPSS output into already, so that you're not doing the actual steps in SPSS but can still work on interpreting the output from SPSS. So starting with question number 4, this asks you to create a correlation matrix for the 3 variables age, level, and score. So remember that a correlation, the SPSS output already kind of sets up the output as a correlation matrix, right? So always the correlation between 2 of the same variables is 1, right? They're perfectly correlated. So this is the correlation then between age and level, the correlation between age and score, and then you'll need to find the last one, the correlation between level and score. So to create your own correlation matrix, you're essentially recreating this just without all of the extra p-values and the n's. So for example, you could set up your correlation matrix like this. You don't need to include the 1 for the correlation between age and level and level. You're free to just do a little dash, but if you would prefer to have a 1 there, that's fine too. And so your correlation between age and level is 0.056, right? That comes from up here. Correlation between age and score is negative 0.154. That comes from up here. And then finally, your correlation between level and score is 0.389, which comes from right here. If it's helpful for you to fill in this bottom part, feel free to do so, but it would just essentially be a mirror image of what's above, right? The correlation between level and age is 0.056, which is already listed up here, for example. Okay, moving on to number 5. This one is asking for what's the strength and direction of the correlation between GPA and exercise, and what can you conclude about this relationship? So first, looking at the SPSS output, remember to look first for the actual R value is listed in the row for Pearson correlation. We see the correlation between GPA and exercise is 0.492. In terms of the strength of this relationship, remember you can use the eyeball method graph and see that 0.492, which is close to 0.5, is within the moderate category for strength. So we say that this is a moderate relationship, and also that it's positive, right? This doesn't have a negative next to it, which means that it's positive. For our conclusion, then, we can say, because it's positive, as one variable increases, so does the other. Remember, positive correlations are when variables move in the same direction. As both go up, or as one goes up, the other goes up as well, right? So one way to interpret this is as exercise increases, GPA increases as well. Okay, moving on to number 6. Number 6 now is one of the full problems, right? That this is looking at asking you to provide the null and alternative hypotheses. I give you the choice here to do this in either statistical notation or sentence form, but I have the answers for both. Explain the type of test used and why, and report your findings in sentence form. Then you're also asked to interpret the coefficient of determination. So first, this one is asking whether or not there's a correlation between hours studied and grades. So recall that our null hypothesis is always this row, right, the correlation in the population. This XY signifies each of the variables. X in this circumstance would be hours of study, Y would be grade, and here we're saying there's not a significant correlation between hours studied and grades. Always, always, always with correlations, your null hypothesis is that there is no correlation between the two variables. Then for your alternative hypothesis, you have a choice. You need to determine if it's a directional hypothesis or a non-directional hypothesis, depending on which this should be different. Your alternative hypothesis is depending on how the research question is worded. So here it says a student wonders whether it's worth his time studying because he thinks students who study more don't necessarily get better grades. In other words, we don't know if he is suggesting that grades improve or they get worse. And so for that reason, our alternative hypothesis here is non-directional, right? We're saying that the correlation is something, there is a correlation. It's something, the R value is something that is not zero, but we don't know if it's positive or if it's negative. So here we say there is a significant correlation between hours studied and grades. Next step is to say what's the type of test used and why. So we say a correlation coefficient was used because we're testing the relationship between two interval level variables in the same group. To make your conclusion sentence, now you're looking at the SPSS output. First line is your R value, and to determine significance, we're looking at the second row. The sig is your p-value. Here we see that a p-value of 0.029 is less than 0.05, so we conclude, because it's less than 0.05, that we should reject the null and say that there is a significant positive correlation between hours studied and grades. We report that we used the R statistic. Our degrees of freedom is 8. Recall that degrees of freedom comes from the n minus 2, so 10 minus 2 is 8. You report your actual test statistic value, and because the p-value is less than 0.05 here, we include that at the end of the sentence. The strength of the relationship is strong. Then the last part of this problem is the coefficient of determination. Recall the coefficient of determination is calculated by the R times itself. So 0.686 times 0.686 is 0.47. We then interpret that as saying 47% of the variation in the dependent variable is explained by the independent variable. In this circumstance, that's 47% of the variation in grades is explained by the number of hours studied. Moving on to number 7. This one is asking to look at the correlation between levels of education and income. So first, we're looking at our null hypothesis, and we'll conclude that there is not a significant correlation between education and income. Recall, always, always, always. For the correlations, your null hypothesis is that there's not a correlation between the two variables. Then you have a decision to make for the alternative. Is it directional or not directional, depending upon how the research statement is worded. So here it says a researcher suspects that lower levels of education are associated with lower levels of income. What that means is that both variables are moving in the same direction, right? As education goes down, income also goes down. If both variables move in the same direction, we know that's a positive correlation. So that our alternative hypothesis is that there is a significant positive correlation between education and income. We use this greater than here because this is signifying that our R value is greater than 0. In other words, if it's greater than 0, it's a positive R value. If instead this had said a researcher suspects that lower levels of education are associated with higher levels of income, that would be variables moving in the opposite direction. Then our sign here would be flipped to less than, and we would say there is a significant negative correlation between education and income. Next part is reporting the type of test used. We know we're using a correlation coefficient here because we have two interval level variables in the same group. Then for your conclusion sentence, you're looking at the SPSS output. Here is our actual R value, but the key part is our sig, right, is our p-value. Again, we see that this p-value is less than 0.05, so we conclude that there is a significant positive correlation between education and income. We report we use the R statistic, 18 degrees of freedom, that's our n minus 2, the actual test statistic value, and our p is less than 0.05. Using that eyeball method, the 0.6 is within the strong relationship range. Again, the coefficient of determination is calculated by the R value squared, so 0.629 times 0.629 gets us a coefficient of determination of 0.40. We thus conclude that 40% of the variation in the independent variable is explained by the dependent variable, or 40% of the variation in income is explained by education. Okay, number 8 now is looking at a data set with 4 different variables. So remember, we can look at as many correlations as possible as we want in one full swoop. So here, this is saying which of these variables are significantly correlated, and more importantly, which correlations are meaningful. So remember, we talked in class about the difference between significance and meaningfulness. So let's do the first part of this first, that's looking at which ones are correlated. So remember, the output is set up essentially as a matrix. This value here is the correlation, is the R value for the correlation between age and shoe size. We see that the p-value for this one is less than 0.05, so we conclude that there is a significant positive correlation between age and shoe size, with our R value being listed here. And again, remember that our I apologize, an error I'm catching, should be 13 for each of these degrees of freedom, so I'm changing all of those quickly. But here we let the reader know that we used the correlation statistic, the R statistic, that we have 13 degrees of freedom, that's our n minus 2, our actual test statistic value, and our p is less than 0.05. Looking then at the next one, the correlation between age and intelligence. This one we see that there is a significant negative, let me start over. This one for intelligence, we see that is not significant, right? Because there's greater than 0.05 for the p-value. So we don't need to report that one. Then the next one is the correlation between age and level of education is here. This one, the p-value is less than 0.05, so we conclude that there is a significant positive correlation between age and level of education. Then the last one, the correlation between shoe size and level of education, is found here. This one, again, we see the p-value is less than 0.05, so we conclude that there is a significant positive correlation between these two variables. When you have this many different combinations, it's important to look at this as a matrix form, right? And ask yourself, what are all possible combinations of these, right? We can look at the correlation between age and shoe size, age and intelligence, age and level of education, and then any of the other possible combinations. The second part of this question then is on meaningfulness. Meaningfulness is very subjective, but using the coefficient of determination can be a good place to start. I would argue that the correlation between age and shoe size is definitely meaningful because our coefficient of determination is 0.88. That means 88% of the variation in shoe size can be attributed to age. That's a lot of it. The correlation between age and level of education, our coefficient of determination then is 0.32, so 32% of the variation in level of education can be explained by age. Probably not meaningful, right? That's not a very high number. Looking at shoe size and level of education, our coefficient of determination is 0.37. Again, probably not meaningful because there's a lot of variation due to something besides the independent variable. And that's it.